Welcome back, Maths Minions. Got something slightly different for us today. Now, anyone that's watched any of my teaching videos or been on one of our MyEdSpace courses with me will know that I love me a bit of CG50. I love me my graphing calculator. I use it all the time. However, when I've taught students that also have one, I do find that their knowledge of just how powerful a tool this thing can be is a little bit tight. So what we are going to do today is I'm going to take you through some of the main areas that I personally use this amazing piece of kit to check my answers as we go through. Before we crack on, please, there should be a link in the video description where you can pop your email address. And what we will do is we will send you completely free a worksheet for you to try out all of these techniques that I'm going to cover in the video, as well as a link to full solutions of how to manipulate your CG50 to solve those solutions as demonstrated by me. So go ahead, sign up for that. We'll be sending that to you immediately free of charge. Now, one thing to preface a lot of this is, here we go. Look, that is a gigantic CG50 over there. You still need to be able to put all your work in. And if you are going for a Maths A level exam or a further Maths A level exam, like, you still need to put all your working down. But what a lot of these things are good for is checking your solutions, right? You can get a numerical answer quite quickly. So we're just going to get going. I'm going to spend a lot of today here in this run matrix area. Now, there are shortcuts in there, but a lot of them will be covered in the other sections. As we're going through this, think to yourself at the end, is there anything else you would like to be able to use this calculator for? And by no means is this video going to be absolutely exhaustive, right? There's a 650-page how-to guide that you can get on the Casio website as to how to use this piece of kit. Obviously, I'm just going through the main ones that I can think of that are of use for people doing maths and A-level maths. So here we go. Here is our screen. Here is our main area here. And we're going to be trying to solve some problems. Now, first thing I'm going to look at is a bit of calculus. Now, to do that, we're going to go options. This is where a lot of the cool stuff is going to live for us here as options. All right, so we're going to click on it. And there a lot of stuff comes up. Now, first thing we're going to look at here is calc for calculus. Now, I've included summation and a bunch of stuff in here. It's mostly because all the tools live in this option here. Okay, so just to redo that, this is what you get here as your main option. If you're ever not sure, just mash exit until you get back to here and start again if you get lost. Right, there's a thing here, maths, where you can get a few bits and bobs that are quite useful. They're basically nice little shortcuts for us if you don't want to go into the options. So I'm going to show you here, options, calc. And we want to do an integral. All right, we want to do an integral, so we're going to go here, bosh. And all we need to do is fill it in. Now, this here is our button. If you want a standard variable like an x, a theta, a t, something like that, and you feel like it should be the obvious one, try this button here. Don't go and find the alphabet x here. It will not work. And you'll see if I go alpha x, that will not work. And again, very self-explanatory. Shift will get you to the yellow parts. If you press alpha, it will get you to the letters, but more on that later. So very basic one that you can use all the time. One of the earliest ones that I started using is this. So we're just going to put in x squared, make sure, yep, we're okay. You can always use these arrows to move through this thing, and then square root of x. I'm going to go right, right, right until I land down here. We can see we can now put our limits in 0 to 10. And there we go. Apparently it's 53350.26. So this should come in as 5350.26. And it's that simple. Now you'll notice this is not algebraic. It is not going to give you the antiderivative, all right? It will not give you any working. So like I say, but if you're working through a question like this and you want to quick check your answer, right? Did you get that t substitution correct? Did you get that substitution correct? Did you do your partial fractions correctly? You can always just get a nice numerical. I think it probably uses Simpson's rule or just trapezium rule. I don't know the ins and outs of how it does it, but the calculator here is doing this numerically. It will sometimes give you a nice one in terms of pi, but there we go. Now we can also do summation, right? We can also do summation like this bad boy here. Now again, we're going to go let's bring the calculator back up, working on many, many screens here. We're going to go exit. All right. Now, two ways to get to these. Because these are quite common maths uses, you can go here, main menu, math, and you'll find a bunch of them here. We can always press this to get to the next part. See, the integral is there, summation is there as well. But I'm going to just go in through the main bit. So option, calc. If we can't find it, there it is. And we can sum up. And you'll notice is exactly the same. Now, we will go root x. Now, this one you do have a little bit more freedom in. E to the minus x. I made this one up, right? This is not of any use because you can tell it what the variable is. But personally, just because I'm never entirely sure what it's doing with its own memory, I just use this one. If it's a variable that I want to use time and time again, I can just use this one. So 0 to 100. So you'll notice I've had to use x instead of r. It's not perfect. So according to this, this should be 0.70724. Sure, why not? Okay. Now, what I do wonder is if that would have worked if I'd gone with r. So square root r e to the minus r. But you can already see it's a bit more fiddly because I'm having to go do that alpha thing every time. But I do wonder if it would work. Let's find out. Okay, it got there, right? But honestly, for ease of use, this button here is your friend. You can use it to sub in R's and X's and all kinds of things. All right, let's clean this up and move on to the next one. Now, interestingly, you can get some really cool stuff done. Now, find the minimum value. Now, normally this would be a derivative. We would do all kinds of things like that. But again, this is not a substitute for actually doing the working, but we can do it. Now, maths, would it be in here? Probably not, actually. So we're going to go, again, options, calcs. This is calculus. And look at this. We could find a minimum or a maximum function. Min, function, max right here. So I want the minimum value of this. So I'm going to go there. And this is sine x. And we're going to make sure we're in radians. All right. If you have a CG50, I will assume that you have looked at how to do that. And we will go from pi over 4 to 3 pi over 4. Syntax is fairly intuitive. I did have to look a couple of things up. You can always Google it. Or your search engine of choice. You can always just get yourself that 600-page how-to guide and look it up, but this is quite a neat one. All right, and this should work. So apparently the minimum will be at x is 3 pi over 4, so it will occur at x is 3 pi over 4, and it will give you a y value of 0.3. And I suppose we could go check this, and this will be a nice opportunity. We'll have a look later at graphing as well. But if I just want to quick graph that, bomb. So it is sine x over x. Now, if you're not sure, you're in any of these menus, you can go shift and go into the setups in theory. No, not the time. Okay. I thought we could shift setup and make sure and change everything in here. All right. So as you would expect. So graphing mode. Go. Let's give this a little graph. And there we go. Now, we'll have a look at this a little bit more in depth. So what's 3 pi over 4? That's about 9 over 4, isn't it? Oh, did I get the correct syntax here? And we can see here the reason it's gone here, which surprised me a little bit, but I completely had missed this. All right, I've put this range here from pi over 4 to 3 pi over 4. This is all of the graph that we have. So the point of this is it is looking for an absolute minimum y value. And it is. The absolute minimum y value is here. if I were to bring back up the old calc and we go look at our graph, if we want to find that global minimum maybe, which is there, we would have to see we're not going far enough. So what we could do is we could go look up here and go, well, tell you what, how about I let this thing run all the way up to 2 pi as a maximum? And here we go, 4.49 at minus 0.2. Again, I'm sort of overlapping with what I was going to do later, which is look at this. But if I just, at this point, look anywhere here and press enter, options, no. So we want to get to there. And I can go, oh, there it is. See this one here, if you want to do fancy stuff, we might just do our graphing right now. So we can go gsolve and we can get all kinds of stuff. We can ask for the roots, the max, the min, but in this case, I'm going to ask for the min. And it's found one for me at 4.49 and minus 0.21, which is the other one we found. And I can go find other ones, I think. I find other ones? No, it's found the app. So that will give you the absolute global minimum. Right. So that is the F min. And equally, we could look at F max. All right. But that is in here. Options, calc. I'd gone over here. F min, F max. We've done some. This is your logarithm. If you want to do your logarithms. That is one of the weaknesses of this calculator. You will see that your log base A, base B is not here. So you have to go into that calculus mode, or here, math. There are some really nice ones that we use quite a bit, which are in there that we can go find. So log base A is in there, but there we go. Right, what's the next thing I want to talk about? Right, now we can find derivatives as well. We can find derivative e to the x over sine x. We don't want to start differentiating that and like we don't. That's horrible. But what I can do, again, exit, 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 exit. We're on our main menu. We're going to go options, and then we're going to go calc, and then look at here. Now, again, it will not do symbolic differentiation for you. All right, there might be ways to do it. I'm not complete. I don't know everything. But if you take this thing into an exam, it will go into, you will have to put it in exam mode, which will prevent you from doing that. But again, the syntax is very easy. I'm using this button here for my variable every time. X is equal to 2. I get minus 0.434. 4354. 0.4354. And in a very similar way, I could find the second derivative. Right? And again, it's fairly intuitive. I can go pick up pi over 2, minus 0.12. 0.6. There we go. All right. So that's a nicer one for us in there as well. We've got our derivatives that we can go for. There are loads of other things in here that you can never play around with. Google, like, do a search online to see what they do, solve n. But I do find personally those particular things you can do easier in other parts of the calculator. All right, let's talk complex numbers. We're going to leave that calc version for a bit. So actually, let's clear the screen for ourselves. And let's do some complex numbers. So we go options and, funnily enough, complex. And this is where you'll find I, and you can do all kinds of cool stuff. Now, what I might do is I am going to, 2 plus 3i. And this is our first foray into storing things. I can store that as z in theory. So now if I just go z, I'll get that. If I go 2 times z, it will do 2 times z. So that's how we store. That's that button there. 4 minus 8i, I'm going to store that as w, just because I don't want to type it all out every time. And really, after that, z times w, there you go. Z times w is 32 minus 4i. that right? 12 minus 16. Yeah, that looks like it works. All right. What's Z over W? Now, there's a couple of things we can do here. Now, I'm going to show you. Now, in this case here, it's not the single most useful function ever, but like Z over W, cool. It should be minus a fifth, right? Z over W is, according to this, is minus a fifth plus 7/20th of I. But you might find yourself in a situation where it gets a little bit trickier. So I can actually go here and go real part. What is the real part of, now if you end your, some of this is a bit trial and error. There you go, minus a fifth. And you could get the imaginary part of it, Z over W. All right, so we get it. You will also notice I could just ask for the absolute value, which is going to be modulus, and we'll do that in a second for Z. All right, but the real part of Z over W is minus a fifth. Now write Z in modulus argument form. Now I can get the, now you could also get the conjugate, right? I just want to mention that whilst we're on the screen. The conjugate, it will do it for you. I'm not sure why you would ever want a calculator to do the conjugate. You're just changing a plus into a minus or a minus into a plus, but you know, whatever. I'm not judging. I'm not judging. But we can get the argument of Z. Get the arg of Z. So if Z is R e to the I theta, this is telling me that theta is 0.9828. And absolute value is what you're going to like, the modulus. It's coming in as abs, which is not a great bit of terminology, but there you go. And we could get R, which is mod Z, which is root 13. But there's an even cooler way to do this. So if I just go Z, right, and that's there, I can go here. Ans goes into R theta mode. Bosh, R theta. Isn't that cool? And we can also change it back to X plus IY. So that's that bit there. So I think that's our little whistle-stop tour of what you can do with complex numbers in here. You can do all kinds, and most things like matrices, vectors will accept complex inputs as well. So don't stress too much about that. All of it can come in. Okay, on to matrices and vectors. It is a bit of an annoyance to get these plugged in, but we can do it now. Again, just smash exit to make sure you're in this. If you want to start inputting matrices and vectors, this is what we're looking for. All right, this button here. See, there's a little arrow there. You'll notice mat_vect comes up in a few places, but that one does not have an arrow in it. This one does. If I go options, this one does not have an arrow in it. So to input them, we're going to go here. Now I'm going to input some matrices. Now I can say what dimension I want A to be. A is 3 by 3, and I can put it in. Oh, I did it earlier. Excellent. I don't think I did B though. So rows and columns. So this would be a 2 by 3. Excellent. -1, 0, 1, 0, -3, 2. And then we can do some vectors as well. U is going to be 1, 2, 1. We might actually, I'm going to make a little note for myself that that's going to be vector A, that's going to be vector B. I mean, by all means, we could go and save them under vector U if we really wanted to, U and V. All right, actually, let's do that. Let's do that. Why not? Let's put them as U and V. Let's do it properly. There we go. All right. And then I can go. Notice the shortcut is all I had to do was actually go alpha and the one that I want. So if I go alpha V, it will take me to vector V. -1, -5, 7. All right, cool. Not much we can do here. So I'm going to just go show you quickly what we can do in matrices, because there are a few things. You can do row operations. You can swap row 1, row 2. I don't want to, but row 1, row 2, we could do it. And now they've been swapped. I'm going to swap them back. Thank you very much. Row 1, row 2. So this is very useful if you want to do some row echelon reduction, anything like that. You can multiply rows up and down. All right. Right, look at this. It tells you k times row m plus row n gets stored in row n. So you can really start manipulating your matrix if you're trying to do reduced row echelon, anything like that. You can play around with it. Okay, so that's in your row operations. You can add and delete rows. You can add and delete columns. And you can just edit different parts of it, okay? So that's everything you can do there. You can change the dimensions. CSV, we're not going to worry about. And we're back in here. Right, now, if we want to do stuff with the matrices, this is where we are either going to go options mat vect, or I can go math mact vet. And again, this menu here is just what they think are very commonly used things, right? So again, I'm just going to go the long way. And if I want to bring up matrix A, I can go like that. Now, one thing I want to bring up here is this idea of the ans function. If I go ans, you'll notice it's bringing up 2. If I go 23 and I go ans, but you notice I had just done a matrix, and the answer brought up there is because the calculator makes a difference between your last matrix, your last vector, and your last scalar. So if I instead go mat ans, it will bring that up. Okay, so if you want to bring up the last matrix you worked with or anything like that, that's what we need to do. But otherwise, it's fairly self-explanatory. I can do matrix A times matrix B, and that's going to give me an error in theory. Actually, I've just realized that is an error. This should be B times A. All right, so AB is an error. Wrong dimensions. On the other hand, BA. There you go. I meant for that to be an error, of course, but it will tell you. Very importantly, syntax error is not the same as math error. Math error means you've tried to make it do something naughty and it doesn't like trying to do it. Not that you told it to do it the wrong way. We could do A times U. So I can go mat A times, it's in here, we keep going, vect to U. So I can't just do A or U because again, that is very important. It makes a difference, right? 1, 6, 4. All right. I could say the number 25 is stored as U. All right. But that is the number U. Vector U is still 1, 2, minus 1. So that's very important to understand that the calculator does make a difference between all your matrices, all your vectors, all your numbers. It stores them in separate places. So you can go check them as you want. All right, so we can do matrix times vector. That's absolutely fine. We can find the inverse, and you're quickly going to see a lot of stuff that we've got here. I can go matrix A, the power of minus 1, and that will give us the inverse of A. A minus 1 is, now annoyingly we might actually, there we go. It looks like it's 1/19 times 1, 5 minus 3, minus 5, 7 over 2, 11 over 2, 7 minus 3, minus 2. Now, one thing I'm going to add in as well. What if I wanted to check the determinant? Now, funnily enough, determinant. Now, again, we can't just go A. We have to tell it it's matrix A. Oh, 38. So instead, I should have probably done 1 over 38 and got 2, 10, minus 6, etc. All right, whatever. All right, determinant is 38. You can also go transpose of matrix A. It will transpose it for you. Right. Rows become columns, columns become rows. A few other things we can do whilst we're here. You can get, there we go, the 3x3 identity. You go identity and 3. I can ask it for the dimensions of matrix A. All right. A lot of this is sort of self-explanatory. Okay. Phil, I can't remember exactly what it does. You'd have to have a play with it. Matrix C. It's because I haven't put anything in matrix C, right? So, but again, this is not an extensive everything you can do. These are things that are useful, things that we do. So matrix A cubed. There we go, matrix A cubed. And you know what? I could store that, and you notice when I go store, it will automatically call it matrix answer. And if I store that as matrix C, right, I can then go mash the exit button, bosh, and you'll notice that matrix C has been saved here, so I can use it again later. Right, dot products and cross products. You might have seen where that lived. Dot product, and if I go vect, and again, it has to be vect u, comma, vect v, that should work, is minus 18. It did it that way. And u crossed with v, funnily enough, we could go cross product, vector u, vector v. And there we go. The order does matter, of course. So if instead I go cross product vector v, comma, vector u, I should get negatives in there, and I do. I think this will just do the angle between them. Personally, I don't tend to use it because it's fairly important to get all your working out, but you could give it a go. Apparently that would be the angle between them. You can, there you go. You can get a unit vector in the direction. So let's get a unit vector in the direction of v, apparently. And there we go, which is just v divided by its modulus, but it is what it is. Okay, so we got cross product, dot product, angle, but notice the syntax of always telling it. And I think normal vector, I don't know actually, if I'm honest with you. Like I said, I don't know how to do everything. Oh, the norm, the modulus of it. So it's the modulus. Okay, so norm is the modulus. So there you go. So we got all of that there for our vectors. Cool. Okay, on to equation solving. So we're going to look at solving some equations. Okay, we're going to look at solving some equations. Now, some of it is fairly straightforward, but we are going to be going away from this part, and we're going to go into the equation solver down here. Now, we'll do simultaneous in a second, but if we just go polynomial here and quadratic, and we can solve it, right? 1 minus 3 minus 20. And there we go. We get our solutions. All right. Big whoop. And we can do it for cubic as well. 1, 5, minus 6, 12. The coefficients, it very clearly labels you which coefficients go where, and especially in terms of the sign of d, they want it equal to 0. Oh, okay. So the only real solution to this one is minus 6.263, and let's actually write that like a real human being. And the other two are imaginary. That's not really the point. Now, how about sine x equals x? So this one is a bit more interesting. Now, you could probably, there is a solve function in the main syntax, in the main run area, but here, we're just going to go to solver. Here's one that I was playing with, but let's just go sine x equals x. Now, there's a few ways to do this. Sine x, there should be an equals x. All right. And there you go. It solves it for you. So that one it will solve for you. You can just put the equation in. And I think it's doing this numerically. We will investigate this later on. X is minus 6.3 times 10 to the minus 8. And basically what it's saying here is it is basically at 0. All right, sine x equals x is true at 0. So that's what it's found there for us. Okay, interestingly, how about if we did cos x equals x? That might be more interesting. Let's find out. Let's change that to cos x equals x. And that one will be at x is 0.7391. So we'll try both later on because I've got a little Newton-Raphson question coming up for us later as well. Now, you can really muck about with this. And this is the one that I had up earlier. You can really muck about. So there's no lowercase t, but I could always go ax, right? So how about we go ax equals e to the minus t squared, e to the minus x squared. I'm using x. You could go capital T if you wanted to. Now, find a when t is 2. So what I can do is change my t, my x, to 2. And if I highlight the a and press solve, that's the a value that should work. And we can check that, in fact, it should be e to the minus 4 over 2, 9.1578, which is what we got. And I realized that my calculator is bang in front of all of this. The more interesting one is solving for t when we have a value of a. So we're going to go back here to equations, to solver. It should all be there. And I can just put in a is 3 and highlight x and go solve, and it will give me the t value. So it should be t is 0.304. You have to be relatively comfortable changing the names of variables because the syntax in this machine doesn't do every single thing we want. You'll notice that if you want to put in variables, it's always uppercase, right? There is a theta there. There is an r there if you want to use them. But that's about that. Okay, so that's our solver for us. Simultaneous equations, not too tricky at all. But I'm going to use this as a little bit of a matrix as well, which is kind of cool. Simultaneous, Bosch, 3 variables, let's go. So -1, 6, -2, 26, 6, -2, -1, -16, 2, 3, 5, 24. And Bosch, there we go. Right, cool. All right, so if we just use the solver, we get -154 over 229. We get 1128 over 229. And we get 484 over 229. Fair enough. Just double checking I plug this in right. 26, 6, 24. Yeah, sure. Why not? Don't know why I chose these numbers. They are what they are. But here's where we can get really cool. Because, of course, we could view this as -1, 6, -2, 6, -2, -1, 2, 3, 5 times by x, y, z is equal to 26, -16, and 24. I want to show you something. So first of all, we could just, let's make a new matrix. 1, 6, -2, 6, -2, -1, 2, 3, 5. And we're going to create a vector A, which is 26, -16, 24. So in theory, if I go matrix A to the power of -1 times by vector A, look at that. So those of us that have played around with vectors, all right, that is pretty neat. What else could we do? I could go augment matrix A, vector A. I might be pushing it here. Okay. Because the other way to solve this is option 2. So this is option 2 with the matrices. We can get that. And option 3 is this should now be matrix A. Has this gone into matrix A? No, it has not. That's still a 3 by 3. So if I go store, if I go options, matrix, answer, and store that as B. Oh, as matrix B. There we go. That's now matrix B. Depending on how you have played around with this, you might be inclined to do the row and sum operations to try and get this into reduced row echelon form, which is where here is. So that is row echelon form. And I would go matrix. We stored that as B, right? And what you'll notice is that you can reduce this to 1x minus the third y z is equal to minus 8/3. This depends a little bit on your exam board, but what we can see here straight away, I've got 229s, hang on, they've got 22. Yeah, 229s. Right, 229s. Once. This is why we're slightly off. Hang on. That should be a -1 right there. There we go. That's why it's slightly off. Which means I need to change this one here. The calculator use is only as good as its user. There we go. 484 over 229. Okay. Now what I could also do is I could go for the fully reduced row echelon form. And you'll notice that I get my solutions there, there, and there. So horses for courses, depending on what we want to do. Let's have a quick look at the list function here. So if I was to use the trapezium rule, but again, if you're doing further maths and you want to do Simpson's rule, it's all the same, right? The main thing we want is to get this list of values out. So we're going to go 0, 2, 4, 6, 8, 10. All right, 5 strips, 6 values. Easily done. We are going to go menu and we're going to go table. Here we go. It's not the one I wanted. So I'm just going to delete everything like an absolute madman. And again, that's my friend there. E to the square root of x. This is one we did earlier, right? Now, type, you can change it into, if you really want to, you can change it into polars, things like that. Set, this will generate the table. So we're going to set. What's our starting x value? Our starting x value is 0. Our end x value is 10, and we're going in jumps of 2. All right, we're going up in 2s. Bomb. Okay, so now we've got them. X is 0, we get 16.45, and they're ready for us to use wherever we want. (1082.8) and 236. And just, you can see that, right, we've got our table is up and running, including my terrible handwriting. And we are ready to rock and roll. You can edit different things. You can get these up exactly. All right. Now, a little hidden bit you can like just play around with some of these things, right? But if I go, that does some stuff. I'm not really sure what, if I'm honest with you, but I'm going to go option. I'm going to go list mem, and I'm going to store this in list 1. Now I'm going to go show you a little thing, because now this is here, fine, lovely. But what I can do is if I go into the stats mode, and we will be doing a separate video for how to use this for statistics, this calculator. But there we go. So the X values have been listed in list 1. So be very careful how we do this. So let's go back to our table, because having the X values is not as helpful as you might think. But if I highlight the second column and go list mem and list mem 2, for example, you could put it in any list you want. This lives in the stats mode for some reason, but there we go. They are all here. But even cooler, if I go back into the main mode, I can go options, list, and I can call up list 2. Even better. And you can call up elements of the list. I could go list 2, and then we're looking for our square brackets. Those of you that do computing will be used to this. Now, importantly, again, this is more for those of you that do computing. It index at 1. So if I want the second element here, this should, if I do it like this, will give me 16.45. All right. And you can really start mucking up here. You can really start mucking around. Because what I could do is I could do, now don't get me wrong, at some point, this is diminishing return, right? Half h times, I would want the first element, so go list 2, plus the last element, list 2, the last one, which is element number 6, plus 2 times, and I think, let's be really, really cheeky, the sum of, and all of this we're going to go x's, so we want elements 2 to 5. This is just me plugging in 5, 6, right? And that's all I did, right? I did the half h times the first element plus the last element plus 2 times all the other ones. According to this, that is 5631.33. Now, what did we get in our original question when we did it? 5350.26. That's not too bad considering how big these are. That's not a bad percentage error, all right? But again, was that saving time versus me typing these out, right? I had to put in the syntax. I want the first element. I want the last element, right? I want twice all the other ones, right? That's fairly advanced maths notation. Up to you, but these are things that we can do. Graph plotting, we've spoken about that quite a bit. I'm just going to take you on a very quick ride around the graph plotting. Again, the other things we can do. Now, a few things that we might want here. So this one is x squared e to the root x. Now, we can't see anything. So you could go V window here and you can change it to where you want it. There's some presets. All right, so we get to see some of it. You could, some presets for trig, which are quite handy. That's just your basic ones. You can store them, but I'm not going to worry too much about that. You could also go zoom. And you could ask it to zoom in on a bit that it thinks is interesting. So it will change the look of it to make it look cool for you. All right, cool. Why not? Sketch. Now, basically, we're playing around with these buttons up here, right? So V window, we've looked at zoom. Let's go sketch. I mean, the inverse. Oh, the inverse function. Fair enough. Don't know if that's useful for me. Ooh. sketch tangent, and I can move it around and it will draw it for me. All right. I don't think it gives me the equation of it, but you can always have a play around and tell me what you think. Don't know what CLS is, never used it. But then Gsolve is possibly the more interesting one. Obviously, this isn't the best graph for it, but we had a little look-see at it with the sin X ones. All right. But that's sort of where we're living in here, and you can have a play around with it. All right. Oh, look, you do the integral. I think you can go enter, and it will find a little integral for you. Some of these you just want to have a play around with, if I'm perfectly honest with you. And finally, we're going to talk quickly about how to use the recurrence relations in here. And that will probably be enough to get us going for this first video. And you will be able to, please do leave in the comments anything else you found that you think is interesting that I should put in a video, or something you would like to be able to do. And we can use that for our next one of how to use the calculators. That's the program. We don't want a program. We want the recursion here, which is number 8. Delete that. Right, so they do it with ANs. Again, you just have to be okay with the fact that it's not going to be perfect. So you put it in there, and again, we're going to go set. So you can put multiples of it at the same time. Right, now, very importantly, these are the n values. Now, whereas the lists, it start counting with element 1, 2, 3. Here, it will start at 0. Now, we could start at 1 if we wanted to, start at 0, start at 1. It's just an indexing thing. Do you call the first element U0 or do you call it U1? So we're going to start at 0 and we're going to go up to the 5th element. That's fine. We only actually need to go up to 3. So we could go up to 3 right there. And this is my starting value of 1. This is if you want to do multiples of them at the same time. Never been entirely sure what the str is, so we're going to leave it. I just leave it as that. And there we go. So the first element was 1, then it'll be 2, then it'll be 2.5, then it'll be 2.9. And you see we've gone up to U3. So we can get these out. We can get the fact that U1 is equal to 2. We can get that U2 is 2.5, and we can get that U3 is 2.9. All right. And you can ask it to do a web plot, but that is not useful. That's one for a different day. Sin X equals X. Actually, let's make it more interesting. Let's do cos X equals X. So what we actually want to solve is f of X is cos X minus X equals 0. So f dashed becomes minus sin X minus 1. So our iteration will be un plus 1 is un minus f at un over f dashed of un. So hopefully this works. So I'll do it with the b's as well, actually. So that's fine. So it's bn minus cos bn minus bn over minus sine of bn minus 1. Let me just plug it all in. We're going to set, we're going to start at, my first iteration of b will be at 1. Let's do a few more iterations. Let's do about 5 of them. And there we go. And we get our first few iterations in the column there. So you can do multiples at the same time, which is kind of cool. And it's looking like it was about x equals 0.739, which is cool. And if we go back up, I think we solved this somewhere in here, didn't we? Where was the solver? I think I did it there. 0.7391. There we go. All right, so that is our first little whistle-stop tour of things that we can use the CG50 for. It's a really powerful tool that you need to use. And this is what we're trying to do here at MyEdSpace, give you tools to really, really unlock your full potentials. On that end, please do go check out the My Resources webpage, which will have a link in the description to this video, which is currently available for A-level maths for GCSE. And you can go there. It's fully worked notes with video examples for all the questions imaginable for your A-level, for your GCSE. So please do go check that out. We've got it for maths. We've got it for the sciences. It's all on there. Link below. Go check it out. And don't forget to like, subscribe, hit the notification, and do drop us a comment. Anything you saw in here that you have an easier way to do, something else that you actually use your calculator for very, very often, please let us know. And we will have more of these coming up, including a how to ace A-level further stats using the CG50. I'll see you then.